Alright, so some of these are going to be kind of repeat definitions and stuff like that, but I feel like it's still good just to kind of go over it again. So, scatterplots, okay, are the best way to study the relationship between two quantitative variables You wasted a lot of time today. Alright, and then time plots, okay, they show a trend over time. Okay, oftentimes these will look similar. Alright, so drawing the scatter plots, okay, to match the conditions. So we're going to have 3 different plots here. Okay, so basically, with little or no association, you kind of just going to have dots all over the place. Yep, super random. I don't even have a purple one today, so you don't have to worry about that. I have pink, this blue color, and then like a teal color. Okay, a moderate negative linear association, so it's going to be sloping downward like that, okay, and they're going to be relatively close together, maybe a little spread out, but still for the most part together. People from my last class are sending me a problem and saying, did I do this right? People from my last class are sending a problem. They're doing the 3 equations, 3 unknowns. X, Y, Z. And then after I did one problem, they're like, we're ready to do this on our own. And I was like, are you sure? They were like, yeah, I'm ready. I was like, you're not ready. And no, that's later. I'm going to make them do it by hand for their first, because I have a test next week too, to get like another test in before the end of the quarter. And what? You'll have to take those, don't you? Yes. But I don't know what the schedule is. I don't know if y'all are just not going to your first classes. I guess that would have to be what's happening. I don't even know what to do for that class now. But anyways, they were like, after one problem, they were like, we're ready. And I was like, okay. So and then a couple people were like, no, we want to do another one. I said, okay, we'll do one more as a class. So we did another one, and they were like, we're ready to do one. I was like, so I gave them one, and it was like the hardest one. Not intentionally, it just ended up being hard. And they're like, we don't understand. Are we doing this right? And I was like, well, yes, but no. Like, we didn't even finish it. I was like, well, we'll finish it tomorrow. Anyways, so now they're asking me if they're right. All right, so then the last one, a strong nonlinear association, okay, meaning it's something that's kind of curved. So maybe something that's kind of parabolic in nature. A parabola? It's not the whole thing. I guess it looks a little more exponential technicality, but. Huh. Like explanatory variable? What is that? Which would be what? X or Y?
Neither.
X. Okay, it's the independent variable. Yeah. Okay, or the predictor variable. How about the response variable? Y is the dependent variable. All right. Suppose you were to collect data for each pair of variables. You want to make a scatter plot. Which variable would you use as the response variable? Why? What would you expect to see in the scatter plot? Discuss the likely direction, form, and strength. Draw a picture to represent the scatter plot. Yeah. Okay. So, I know I'm going to need a plot. Okay, what should be on the X and what should be on the Y? So number sold affects the price. I don't know what it is. I can't tell. So price is what's going to affect the number sold, okay, right? If you go to a store and they have something that's $1, and they have something that's like $10, you're more likely to buy the dollar item, right, if it's the exact same thing, more or less, okay. So the price is affecting the number sold, so price is going on the X. No, you don't smell that? Yeah, it does kind of smell like. Oh, speech class? Speech class. I don't know what they're eating, but. Oh, how exciting. I know Brandon was making tea. Yeah, because I wanted to eat. I made chocolate pie for mine. I did in college. We weren't allowed to have one when I did mine for, well, because I did it in college. I didn't take speech here. So we had to do it as if we were on Shark Tank when I did it, because like I said, I didn't do it here. So we had to basically sell an item. So I was selling my favorite ink pens. At the time, they were some like Bic Ultra something. All right, so we would expect this to have what kind of a correlation? Basically, as price increases, what do we think happens to the number sold? Price increases, the number goes down. Yeah, to me that was positive, but I realized to you that was probably negative. Okay, so we're going to expect it to do something relatively speaking like this. Okay, so negative, probably linear, probably strong. Yeah, but you know somebody else is going to put out the exact same thing, like $400 cheaper. And then people are going to buy them.
How do you rip off a freaking wheel? For your desktop.
octagons.
I don't think they can put a hat on a freaking turtle.
Yeah. All right. This one. All elementary students weight in the score on a reading test. So what do you think affects the other one? Or if it does?
Weight affects the score.
So meaning weight goes where? I'm pretty sure this means the weight of a kid, but yeah. But if it was the other way, if it was the weight of the test, the score would be on the X, because then the score would affect the weight, right? Yeah, but like if you have like a point system though, if I give you a test out of 100 or a test out of 150, like if we were purely a point system, the test out of 150 would be worth more. It'd be weighted higher. if you justify your answer, it's fine.
Well, because like I don't know, 'cause right now our tests are like for pre-cal are like 50% or 45.
Yes, but I do a percentage. So I'm saying if you're on a point system like Miss Marshall, where it's purely points based. So what do we think is happening? As the weight goes up, what happens to the score? Maybe it's supposed to be weighted. We'll just say it's weighted a test, because that would make more sense. How likely they are to study.
The fit person does bad, they're like sports or something. That person's doing bad because they're just sitting on their couch.
Okay, so his weight increases. So the weight of the test increases. What's happening to the score in theory? We would hope so. Now, as the kid gets heavier, we can't guarantee that. Okay. We're just going to say...
Wouldn't this also be like the little or no association one?
Probably, I would say it's probably moderate rather than, like, strong. So, positive, linear... Probably moderate. Could have outliers. Because you could have a really, really chubby kid that does really well. Or you could have one that does really bad. Yeah, I think we should specify this is the weight of the test at this point to verify that in case anybody goes back and watches this and is like, what are they talking about? They're back and forth between a chubby kid and a skinny kid and a high-weighted test and a low-weighted test. Yeah, you're going to be like, what? need to get a class mic that will, like, allow me to push a button and hear what y'all are saying on the video. Okay, in some classes it would not be good. In this class it would make so much more sense. Yeah. No, especially if I put it in that back corner over there. All right, correlation. Okay, the strength of the linear association between two quantitative variables Did you see what I wrote? It's quantitative. This is how you know we need a long weekend. Okay, we're looking at something that's -1 less than or equal to r less than or equal to 1, so it has to be in that range. R less than or equal to 1. The correlation coefficient. Okay, we're looking at the absolute value of R. Okay, if it is close to 1, very strong linear. Association, an absolute value of R that is approximately 0, no linear association. I would just see if the book specifies like what value for sure makes it weak, like whether we would consider it strong or moderate or weak or no. So just always make sure, though, like if we don't specify what it is, make sure when you give the name, like if you tell me that it's strong, make sure you show me what that coefficient is, if I don't ask you about the coefficient, or if it's just a question that says, would you expect this set of data to be strong, weak, moderate, no, like whatever correlation, then you can just tell me. But if it's one where you've had to like solve the correlation and you're telling me in words what it is, make sure if it's like strong, you tell me like the number. So like say like it's neither. So it's just a coefficient. So it's technically speaking, nope, just kidding. It's not. It's just a number from -1 to 1. So if it was, let's say if it was -0.9, okay, you would tell me that it is a strong negative association. Huh? I didn't even look. Literally haven't even flipped the page yet, so. The second page apparently has what I just answered on it. Okay, so draw a scatter plot representing the following correlations. Okay, so this would be, just in words, okay, this would be a strong, negative, linear, okay, association. Okay, so we would expect our scatter plot to be basically something like that. 0.764, what do you think? No, weak, moderate, or strong in terms of correlation? Yeah, so I would say probably as a general rule, okay, this would be moderate. Moderate and it's positive, so we'll go ahead and say moderate strong, okay, because it's on the higher end of it. Okay. I think we could probably go ahead and just make a general rule that says basically anything plus or minus 0.8 and above, okay, so absolute value of that stuff, okay, is strong, okay. I would say something like plus or minus 0.2. Okay, or below, okay, meaning from negative 0.2 to 0.2, we could probably say is weak. Yeah, anything in between is moderate. Yes. Okay, anything in between we would say is moderate. As we get really, really close to 0, we would say no. N-O, no. Okay, here we have moderate, strong, positive, linear. Okay, meaning that we're looking at something that's still going up, relatively strong, but it's not all compacted, like right there together. The pouch in those masks is always on the right. So if somebody tells me that, I just stick my finger there and see if there's see if the hole's on the right side. I think she heard me say that one day though. Oh, you can try it and see what she does.
Okay, I didn't believe you, but I took it off and then I just threw it on the ground. If I had checked, I would have been like.
All right. All right, what would this one be? Real weak or what? If it's close to 0. No. No linear. So then just there you go. It is fun. All right, let's go ahead and try to get through 4, and then we'll probably save 5 for tomorrow. All right, antidepressants. A study compared the effectiveness of several antidepressants by examining experiments in which they had passed FDA requirements. Each of those experiments compared the active drug to a placebo, an inert, is that right? Yeah, an inert pill given to some patients. Okay, meaning, y'all know what a placebo is? Basically, it's like there's one that's like the actual like drug that they're testing on somebody, and then some other people get something that's just like a sugar cube or something. But it looks the exact same, so they don't know what the difference is. Yeah. Yeah, so like but you don't know what you're getting. So some people are going to get the placebo and some people are going to get the real thing. Well, this is like clinical trials, so like, hold on, we'll get there. Okay. In each experiment, some patients treated with the placebo improved, okay, and in a phenomena called the placebo effect, okay, meaning that they think their sugar cube worked some magic, okay. So in theory, it fixed their depression with a sugar cube, okay, because it's a mental thing Okay, I'm not saying depression. I'm saying the placebo is a mental thing, okay? It's thinking that, oh, they're giving me something that's working, and then magically it works. Now, it doesn't work for everybody, but for some people it does. So, patients' depression levels were evaluated on the Hamilton Depression Rating Scale, where large numbers indicate the greater improvement. The scatter plot below compares mean improvement levels for the antidepressants and placebos in several experiments. Okay? So it's showing you the placebo improvement here. Okay? Just so you guys see, because we haven't really had one where this has happened, this number up here that's kind of half circled, we would probably say is an outlier, just because it's kind of off from the rest of the stuff. Okay, so this is drug improvement versus a placebo. Okay, is it appropriate to calculate the correlation? Yes or no? Could we calculate the correlation here? I'm not asking you to calculate. I'm saying would we be able to given the known information? Okay, so yes, okay, big thing is here we have quantitative variables. Okay, we have to have quantitative variables. If we don't, we can't do it. Okay, the scatter plot looks linear, so we would be able to find a correlation. Now there could be an outlier, which we've already kind of mentioned, so we don't have to rewrite that. Okay, then the next question says, the correlation is 0.898. Explain what we have learned about the results of these experiments. Okay, strong, positive. Yep, strong, positive, linear association. Okay, between, you'd want to specify this, placebo improvement, and drug improvement. Okay, so basically then we could also say here, if the patient shows strong improvement with the placebo, they are likely to see an improvement with the drug. So we'll probably get through a couple more examples tomorrow.